Right, welcome back to another video. More maths today. We're going to be going over some quite cool stuff, getting away from some of the more pure math nodes and looking at more sort of the some of the inputs we can have to our shaders and how we can use those to build up various techniques and things. But slightly off topic one first. We're going to be talking about edge pixels. So every texture that we import into Unreal has edge pixel or tiling methods. So they're hidden away, excuse me, hidden away underneath these little arrows. And this one, it's just a simple black and white texture. It's way too big for what it is, but it's demo purposes, so don't worry too much about that. But it's black on white, black on one side and white on the other. And because I've set this to clamp, so the default would be wrap. If I just do that and have a look at what that looks like. Let's just recompile this. So all I'm doing here is I'm using a sine wave to move our texture black and white in the x-axis. So it's just scrolling back and forth. And you can see if I've set it to wrap, it just repeats those pixels, it just tiles. So we're getting this kind of like weird sliding bars effect. Cool, might be what you want. But if we clamp that edge, what's going to happen is as we go across, away from the 0 to 1 UV square, so as we go over this side and as we go over this side, it's just going to repeat that edge. So this black is going to carry on black forever, this white's going to carry on white forever. And if I save it and go back and then just recompile, update my preview, you can see we're getting completely white to completely black. And this is obviously something that could be animated via parameter. Really nice way to create something moving along a mesh, kind of something like that. There is also mirror. I've never ever used this, but it exists. So I think it's a hangover from the old days where you'd have a character's face would be mirrored and you couldn't afford textures on both sides. So you'd make half a texture and paint them, and then you just mirror it and it would unwrap to the other side. So here I've made a quarter of a circle, set it to mirror, and if I set it to be a 2x2 tiling, I get my whole circle. So like I say, I've never really used it for anything. That makes even less sense. 2 being a full circle, 3 is going to be a circle and a half. So it's every time it goes into that second alternating UV shell, sort of UV square, it's going to be repeating, but repeating the opposite way around. Yeah, useful for symmetrical characters, that kind of thing, maybe, but these days you probably want the left and right sides of your characters to look different anyway, little micro details and stuff. I'm not making PS2 games anymore, unless you are, in which case, good for you. So, edge pixel tiling, moving on. It doesn't quite fit with anything else we're doing today, but it's one I wanted to include. I want to talk about pixel depth. So, what have we got going on here? Well, I've got this grey sphere, and as I move closer to it, it starts to fade away. This is a really useful technique for when you want kind of like big sandstorms, fogs, smokes, anything like that. If the player walks through them, you probably don't want to see that clipping as they kind of cut through that plane. So we can use some input data to fade away. So what we're using here is the pixel depth input data. It's just a node. Pixel depth, there it is. And what does it do? Well, it gives us the distance from the camera to the pixel that's being rendered. So if I open up my visualizations, I have one here. Okay, it's not one we can actually preview, I don't think. But you might have seen depth buffers, depth maps. If I just do depth render, that's really a good thing to find it. You might have seen these kinds of things. This is just rendering a 3D scene where the colour of the pixel is the distance away from the camera that's being rendered. It's really useful in compositing. You can build some nice sort of fogging effects out of it, and it's part of the render pipeline in Unreal as well. And so similarly, what we're doing is going to be using pixel depth. So that's going to be the distance to the pixel that's being rendered. And then all we're doing is a little bit of maths, subtracting from that first to give us an offset, and then dividing it to give us a scale. So the first value offset is how close we have to be before it starts fading out. not going to recompile without being able to do it. So if I change this up to 500 now, 500 units away, start fading. And then this scale is how quickly we're fading, so 500 as well. That fades out a lot slower as you get closer towards it, which is pretty cool. As often is the case with Unreal, there is a function inbuilt that does this, camera depth fade. See, it's a bit of a mess. It's pixel depth, subtract, and a divide, and there's some other options up here that we're not going to worry about. So, pixel depth, yeah. So that's a way we can do to create sort of a near fade based on some input data, which is pretty cool. Now this is only ever looking at the distance from the object to the camera. Quite often we want to compare this object to another object. So how do we do that? Well, if I open this next map, this is the depth fade. And you can see here we're getting a nice soft transition between our sphere and our ground. As I move that up and down, it's all built into the shader, it's all dynamic, so it's not this painted mask out or anything like that. So what's this one doing? I open up my material, similar thing, start down here, so it's using the pixel depth we just talked about, that's the depth to the pixel being rendered, and it's also using the scene depth. Well, scene depth is what I was showing here in the depth render. So the scene depth in Unreal doesn't take into account any translucent objects. So it's the first opaque pixel being rendered. So if I just hide this sphere, our scene depth is going to look like this, and we can preview that. Scene depth. There we are. So here we got this slight kind of grayscale gradient across our cube, off our floor. This object's so far away that we're starting to get these banding errors. Don't worry too much about that. But hopefully you can see that that kind of far corner of the cube is a bit lighter than these pixels down here, because they are further away in the scene depth. Well, if I've got this as 1, and then I've also got the sphere position being rendered as well, I can compare the two. And where the two coincide, i.e. the depth to the pixel being rendered and the depth to the first opaque pixel behind it being rendered are the same, if we subtract one minus the other, we'll get 0. And what do we know, what we can do with 0 in our opacity is going to make it fade out. So same kind of thing here, we're comparing the two input datas, the pixel depth and the scene depth. We can kind of do some maths to them. And this is inbuilt again as a node. It's just called depth fade. So this isn't a function, this is just like a hard-coded node. But what it does is exactly that. So this is the fade distance, this is the distance away from where that intersection happens. And it's just giving us a way of fading in and out these edges. Nice and dynamic. Really useful for any kind of transparent sprites. Can't really get away with hard edges anymore. People will see. Also, we can use this for other things. Again, they're just black and white data. There's just masks. So here, if I plug this into an emissive, take away my opacity, and use the same logic, the same maths, to create an edge fade, an edge glow between two things. You ever had like a sci-fi shield? See there where it doesn't work because it doesn't have the intersection between things. So it's pretty cool. Pretty powerful technique. One thing to notice, potentially notice, I don't know how easy it is to see with this, but it's view dependent. It depends which angle you're looking at, how wide that strip's going to be. And there's other ways to do that, but I'm not going to those now. But just note, obviously if you're doing a very shallow angle, the distance between that pixel, if you think about how the triangle works, the more above you are, the more you're kind of like, the depth is there. That makes sense. So, simple way of using it, just adding it into the opacity channel. Give us a nice fade out along that edge. Do more advanced things as well, where we create kind of edge masking that's automatic. Some result both. So cool. So that's the pixel depth and scene depth inputs. Next one I want to talk about. I'm going to come back to the world position and we're going to look at object position. So what's this map here? What's going on here? Lots of glowy things. Well, if I take this object, this cube, and I reset its position back to 0, it becomes black. If I move it ever so slightly in Y, the green axis, so just literally 1 unit, it goes green. 1 in red, it goes red, and 1 in blue. Oh, must be more than 1 in blue because of where it started. If it's not in the right place, there we are. You can see, hopefully, what the colours the object is being displayed as is the colour representation of that world position. So up here, these values, 200 or 300 something, 300 something, these values are huge, so we're getting this super bright glowy cube. Just open the material, what's going on? We're literally just plugging in the object position to emissive colour. And object position is reading the data from this location. This is the position the object is in. Well, when we're dealing with very big numbers, it makes sense to scale them down. So this object is moved quite a lot in the green axis. I can control how bright that is using the sort of scalar parameter here, just scaling it up and down. That makes it into a more usable set of values, gives us control. Yeah, fine, cool. I took that and moved it across over here into red. That's going to be red because it's representing that world position. And what's nice about this is it's the same value across the whole object. There's no gradient across this. All pixels that are rendering are all taking that same position because the object only has one pivot point, only has one position. And we can use this to drive any part of our shader. It's all just numbers. So here I've hooked it up to the UV. As I move this object across, I'm panning the UVs at the same time. If you can see that. Let's make a few of them. They have slightly different UV settings depending on where they are in the world. And our scale will control that. We have a very high scale, doing very little. See, too aligned. Make quite a lot of variation. And we can set this up to do anything. So maybe we'll multiply. So here I'm just taking the the green channel, sorry. So anything across this way is going to get a slightly different offset. The panner. I could say take the same thing, mask out. Say red. Just going to use that. Divide by the same scale for now. Useful numbers. And maybe, I don't know, stick it into a sine wave. What's this do? So I'm just taking a repeating or infinite set of numbers, making them repeat. If I move these objects across in X and Y, you can see the tiling scaling up and down based on the number position. So you wouldn't necessarily think it to see them, but all three of these shaders, or at least three of these cubes, are using the exact same shader. And all that randomization, all that variation is coming purely from the object, from the object's position. So it's a really powerful way of creating a lot of variety, a lot of randomness. If you need to build it into your shader, then you can. Finally, for today, I'll have a look at the world position node. So what we were looking at just then was object position. Save these things off. And the object position is taking the object pivot point and then relaying that information into the material editor. Similarly, if I put this one back to 0, we're still getting this black in this corner. Well, actually that's negative numbers that Unreal doesn't know how to display, but it is going red in the x-axis and green in the green channel. I scaled this up and moved it up into blue. You get blue. So this time the position node, which is this code, it's called absolute world position. To find it in here, you just type world position. If you start typing absolute, it won't find it. It'll find the absolute maths node instead, which isn't the best thing, but there we are. World position, absolute world position. This is the per pixel location. So before we had object orientation. Oops. Object position. So this object position is for the whole object, and it's just the position of the pivot. And this world position is the per pixel position, but it's the same data. It's the same position in units in world space. We have a look under here. All I've done here is I've just clamped it 0 to 1, so you can start to see those different things. Again, another way of dealing with high numbers, bringing them down. We probably want these to be divided. But what else can we do with them? Well, how can we use these? Well, if we have a look at this, just scaling my world position values down. I'm then masking out the red and the green channel, and if I put this at the origin, move it to about here, does this remind you of anything? Does it look like anything else? It looks like UVs, doesn't it? It's the same as the UV text chord node, and in fact we can do exactly that. We can take our we can take our world position node, divide it by a value to give us some control of the scale, and then mask out 2 channels. So if I masked out red and green, that's what I had in my preview. You can hopefully see how this texture has been projected. It's being projected down onto our mesh, and if I scale it down, you can see the edge pixels are smearing, because as it's projecting down, it's projecting all the way down along that edge. And this is very, very useful. So anything that's going to be mostly flat, for example, terrain, water, stuff like that, it's going to be quite useful to project that down, because what happens is the edges between pieces, you don't need to make them line up because they're being textured by a projection. Let's find this and apply it to the cylinder I made. See how the texture kind of like wraps up and across. So anyway, you've got a little bit of mesh, maybe a rock has a little sort of skirt around it, wants to match the terrain underneath. If you project those textures, you'll get a nice result. You'll get it to kind of like match up perfectly, because you're not using the UVs of the object, you're actually just projecting in Engine, which is really, really powerful. This was masked by red and green. Well, if we look at our axes down here, red and green is our XY, that's the flat plane. We could also mask by, for example, red and blue. Red and blue is going to be the XZ plane, so we're going to be projecting from this side. See, we're doing that. It's just smearing along the top. So, top-down projection, a bit more useful. That makes more sense. If you're making like a 2D side scroller, maybe some sideways projection you could do. But there's nothing stopping you projecting all 3 axes at the same time. And when you know it, it's something that exists in the engine. It's this one here, world aligned texture. I'm not going to go exactly into how it works, but maybe I will in a minute. If we take this and then project it along, you can see these cubes are all nice. Actually, if we look at this sphere, we do start getting some smearing here. So it's actually what it's doing is it's taking the 3 different projections, top down, X, Z and YZ, and it's just blending them based on the angle. And it obviously, where those angles don't fall on one of the sort of the main 3 directions or main 6 directions, you get this smearing. But if this was like a rock or something a bit more noisy, this is about the worst possible texture you could have for this kind of blending. And if I change this to, I don't know, some noise, say Perlin noise, for example, I just apply that. Very difficult to see where that smearing's happening. A little bit of fading maybe there, but obviously a lot better than it was with the sort of the UV map. So let's see that back in. So yes, that's the world position node. It's very useful. Projecting textures, that kind of thing. Really, really powerful. Use it a lot in VFX or for say terrain, water materials, stuff like that. Oh, that's not the right thing, is it? There we go. That's why it's not doing anything. Make sure your nodes are connected. Yeah, and this scale value is giving us control of that tiling change, and we get a nice projection across multiple objects. So, as always, I hope that was helpful. Let me know any questions, comments, etc. In the email address below, and I'll see you all next time.